So in this video, we're going to go ahead and graph vertex form, so of a quadratic, and that is y equals a x minus h squared plus k, where h and k is your vertex and x equals h is the axis of symmetry. So we have the first example here. It says graph f of x is equal to x minus 3 squared minus 2. Find the vertex and any x-intercepts. Okay, so the format is ax minus h squared plus k. So then that means that h is equal to 3 and k is equal to negative 2. So therefore, the vertex, remember that's hk, so that is equal to 3 comma negative 2, and that would be our vertex. So let's go ahead and graph that. So 3, negative 2. All right, and then we're going to go ahead and find the intercepts. So remember, to find the x-intercept, you're going to set y equal to 0 and then solve for x. So y is actually f of x, so 0 equals x minus 3 squared minus 2. And actually, this is the square root method, so you could actually add 2 to the other side. You get 2 equals x minus 3 squared, and then you could square root both sides, plus or minus. And then you're going to add 3. So therefore, x is equal to 3 plus or minus square root of 2. And then we're going to go ahead and find the decimal for that. All right, so I went ahead and plugged that into my calculator, and I got 4.4 and 1.59. So let's go ahead and put that on the graph. So the x-intercepts are 4.4, so about here, and 1.59, so about there. And then don't forget the axis of symmetry is your h, so that's 3, and that's going to be a vertical line going through 3. So we're just going to go ahead and dot that. And then the last thing that we need to find is the y-intercept. So y-intercept is set x equal to 0 and solve for y. So remember, this is equal to y, so y equals 0 minus 3 squared minus 2. 0 minus 3 is negative 3. Negative 3 squared is 9, and 9 minus 2 is 7. So the y-intercept is 7. So 1, 2, 3, 4, 5. So about there. And then we could go ahead and graph this. And that would be our graph. All right, so we're going to move on, and the axis of symmetry formula. So there is a formula for the axis of symmetry, and that is x equals negative b over 2a, which is also the x-coordinate of the vertex. Okay, so example number 2 says graph f of x is equal to 3x plus 3, or 3x squared plus 3x plus 1. Find the vertexes and any intercepts. So we're going to go ahead and graph this. All right, so we have the formula x equals negative b over 2a, which is that, remember, it's the axis of symmetry, but it's also the x-coordinate of the vertex. So we're going to go ahead and plug that in. So b is 6, that would be negative 6 over 2 times a, which is 3. So that would be 3. And then you get negative 6 over 6, which equals negative 1. So now we have the x-coordinate of the vertex, but we have to find the y. So to find its pair, what you have to do is plug it back into the original. So y equals 3 times negative 1 squared plus 6 times negative 1 plus 1. So this would be 3 times 1, which is just 3. And then that would be minus 6 plus 1. So this is going to be negative 3 plus 1. So negative 2. So the y coordinate is negative 2. So let's go ahead and graph that. So negative 1 and 2. So there's our vertex. And remember our axis of symmetry, you should always draw that when you're drawing a quadratic. Is going to be the x coordinate. So x equals negative 1. And then the only thing that we have left is the x-intercepts. So let's start off with the y-intercept. That's when you set x equal to 0. So y equals 3 times 0 squared plus 6 times 0 plus 1. So that's going to be 0 plus 0 plus 1. And therefore it's just 1. So my y-intercept is 1. Next we have the x-intercept. So that's where you set y equal to 0. So we have 0 equals 3x squared plus 6x plus 1. And then this is the guess and check method for factoring. And I guessed and checked a couple times and it didn't work. So what I'm going to do now is just use quadratic formula. So a is equal to 3, b is equal to 6, and c is equal to 1. So quadratic formula is negative b plus or minus b squared minus 4ac all over 2a. So this is going to be negative 6 plus or minus the square root of 6 squared minus 4 times 3 times 1 all over 2 times 3. All right, and then I'm going to go ahead and simplify what's inside the radical. So that gives you square root of 24 all over 6, and the square root of 24, that is going to be 2 radical 6. And then you want decimals. So we're going to go ahead and find the decimals of these. So I plugged it into my calculator and I got negative 0.18 and negative 1.81. And the reason I converted it to a decimal is so I know where to graph it on the graph. So here's the first one, negative 0.18, and then this other one, negative 1.8. And then we could go ahead and graph. And then I'm just going to make sure to label my graph. And then we're done. All right, and here's our last example. So it's a word problem. A rock is thrown upwards from the ground. Its height in feet above the ground after t seconds is given by the formula f of x is equal to negative 16 t squared plus 20. Find the maximum height of the rock and the number of seconds it took for the rock to reach its maximum height. So we're talking about something that is being thrown this way. And if we're trying to find the maximum height, we're trying to find the vertex. So if you're ever trying to find the maximum or the minimum, it's always going to be your vertex. So we're going to need to find negative b over 2a. And here, a is equal to negative 16, b is equal to 20, and c is equal to 0. So in this case, our variable is actually t, so x takes the place of t. So we're going to say t is equal to, and then we're going to go ahead and plug in our values. So negative 20 over 2 times negative 16. And then we get negative 20 over negative 32. We could punch that into the calculator and we're going to get 0.625 seconds. And that's how long it takes to reach the maximum when you throw the rock up And now we need to find the length. So we're going to plug it in. So we have y equals negative 16, 0.625 squared plus 20 times 0.625. Okay, and so I get 6.25, and that is in feet. So in 0.625 seconds, it goes up 6.25 feet up in the air, and that is the maximum.